Assalamu alaikum everyone. So today we are going to start kinematic questions from the paper 2023, right? So let's begin with first question that we have. They're asking us a ball is kicked upward at an angle of 45 degrees. So we have the theta to the horizontal ground. After a short flight, the ball returned to the ground. It may be assumed that the air resistance is negligible. Its mean acceleration will be equals to g. What is never zero during the flight? Okay, so it's a projectile motion. We know a few things about the projectile motion as discussed in the previous video, that horizontal component will always remain constant. Horizontal component of velocity, the initial, the final, they will be equal and they are always constant. Why they're constant? Because there is no horizontal force that is acting, so there will be no horizontal acceleration. Okay, because there is no air resistance, the only acceleration is vertical acceleration, that is equals to g, right? So there will be no change in the horizontal, so the option will be B. The horizontal component of the ball velocity will remain constant, right? And it will never be zero. Vertical component will change, and at the maximum height it will be zero. So when the velocity will be zero, the momentum will also be zero. Okay, so these all options are incorrect. Okay, in the second question, the graph shows the variation with the time t of the displacement s of the object. Which graph represent the variation of time of the acceleration a of the object? So what we have the options. Okay, we have the acceleration time graph below, and we have to tell which graph will be sync with this one. Okay, so if you see, if we interpret this one, it's a displacement time graph, and we know slope is equals to velocity, and we know change in velocity is equals to acceleration. Okay, so that is how we have to look at this graph. So if you see, straight line always show a constant slope, so this is a constant slope, so I can say this is constant velocity. It's mean a is equals to 0. Okay, same as this is also a constant velocity, a will be equals to 0. So all the straight lines are constant velocities and a is 0. Apart from these chunks, if you see at these points, what is happening? The velocity is changing, right? The slope is going from positive to negative, so velocity will change. So at this point, and at this point, and at this point, velocity change, and that thing leads to acceleration for a very short time. So if you see, this is the right option, because at a very short time you will get the acceleration, and then there will be no acceleration, zero acceleration. Okay, so this is the best fit. In the next question, again we have the graph, but these are the velocity time graph. What they are telling us, which graph represents an object falling from the rest through a long distance in the earth atmosphere. Okay, in the earth atmosphere mean there is air resistance. So when something is moving in the earth atmosphere, downward force acts weight, upward force acts the air resistance. So with the journey, object will keep on speeding up until we can say weight will be equals to air resistance, right? It's a terminal velocity concept basically. At this point, velocity will be constant. And when the velocity is constant, that thing is called terminal velocity. So what we have to look, the journey is increasing velocity, and then velocity should be constant. Acha, if you, as these graphs are the velocity time graphs, so we can also discuss the acceleration as well. So at this point, at the start, acceleration will be maximum. Why? At this point, a will be maximum, and at this point, a will become 0 because velocity is constant. So velocity acceleration should be decreasing and go to 0. So you have to look at the decreasing slope. This is not a decreasing slope. This is a constant slope. This is a zero slope. Um, this is a increasing slope, and this one is the decreasing slope. Okay, this is constant acceleration. This is zero acceleration. This is increasing acceleration, and this is decreasing acceleration. So D is the right option for this thing. Okay. So the next question: one object moved directly from P to R. This is point P. This is the initial point. This is the final position where it go. In a short time, a second object moved from P to Q and then R. Which statement about the two objects is correct? Okay, one object is taking this journey directly from P to R, and there is another object that is moving from P to Q, then moving Q to R. Okay, in a shorter time. So it's covering more distance in less time. So it should move with a higher speed, right? So in statement, they have the same speeds wrong. The thing that is covering more distance in short time will be moving at higher speed. So they will not be of the same speed. They have the same average speed. No, average speed is total distance over total time. They have the different total distances. They have the total different time. Okay, then they have the same displacement. Yes. Displacement depends on initial and final position of body. So if you see, both were at point P and both are moving to the R. So displacement will be same for both of them. So you have the option C. In the next question, a ball is kicked so that it has an initial velocity of 12 meter per second at an angle of this 50 degree to the horizontal. Assume A resistance is negligible. It's mean A is equals to G. You have to find the maximum height. So S is equals to H that you have to find. Okay. It's again, you have U, and if you have to find the height of that thing, this ball will move like this. It will reach the maximum height. You have to find this thing. Okay. So at the maximum height, we know the vertical component will be equals to zero. At this point, the vertical component of velocity, you can say it will be 12 sine of 50 degree. So you know U, that is, we are talking about vertical components. Okay, only 12 sine 50. We know the final velocity, that will be zero at the maximum height. Obviously A is equals to, as it is moving up, so A can be taken as minus G. Okay, but and distance is H that you have to find. So we have to think about the equation of motion that does not need the time, so we can use V square is equals to U square plus 2A S. Putting the values, we have final is 0, initial velocity is 12 sine 50, and they should be whole square plus 2 into minus 9.81 into H. So H will be equals to 12 sine 50 whole square divided by 2 into 9.81. So when you calculate this thing, it will give you 4.2 something as option C. Okay, let's move to the next question. A camera drone of mass 1.2 kg hovers at a fixed point above the ground. The drone has a four propellers. Okay, so we have the mass of this thing, the drone mass 1.2 kg, and in a time of 1 second, each propeller pushes a mass of air, this much mass of air you have, vertically downward. Assume that the air above the propeller is stationary. What is the speed of the air leaving the propeller? So you have to find the speed of the propeller. Okay, so if you see, this thing is balanced, it is at a fixed point, right? So if it is at a fixed point, it's mean what we can say about this thing, there are two forces, one is the weight and one is the propelling force, that is because of the air that is acting upward, right? They should be equal. So I can write it as mg is equal, this propelling force can be known from the Newton's second law, it's change in momentum over time. F is equals to change in momentum over time, and weight is equals to mg, so they both will be equals. Okay, and mass of, on the left hand side, this mass is of the drone, that is 1.2, right? G is 9.81. Change in momentum is, acha, what the change in momentum we consider, this change of momentum is of the air that is causing the propelling force. Okay, so there will come mass into velocity divided by time. This mass will be the mass of air, keep in mind. So this is 0.40 into v, and time is 1 as given, 1.2 into 9.81. So V will be equals to 1.2 into 9.81 divided by 0.40. So that thing will give you, when we calculate this thing, 1.2 multiplied by 9.81 divided by zero point 0.4, it will give us 29.43, that is the speed. Okay, this is for the four propellers, right? Combined velocity of them. But what we need to tell, each of them. So total there are four for each. So what you have to do, you have to divide with number of propellers divided by 4. So you have to divide this thing with 4. That will be 7.357 and 7.6. Okay. So option C. Okay, the next question, a ball traveled from point X to Y around a semicircular track of radius 1. What is the displacement of the ball? Okay, so as we have discussed in the previous question, displacement depends on the initial and final position. So it's moving from X to Y. Okay, so this is the displacement is a vector quantity, so you need the arrow as well. So as you know, from this is a semicircle, from this point to this point, it is the radius, that is 1.0 meter, and same goes for this thing from this to this. So 1 plus 1 will be 2, and it's moving to the south, so it's option B. In the next question, a rock is launched vertically upward from the surface of the earth, and an identical rock is launched vertically upward from the surface of Mars. Okay, so we have Mars, we have the earth. Each rock is launched with a velocity of this initial velocity we have. Each rock then reach its maximum height above the surface before running back to the surface. The velocity time graph for each is shown. In both cases, A resistance is negligible. It's mean A is equals to G. This is the graph we have. What is the difference in the maximum height of the two rocks? Okay, so if the rock is moving, let's suppose this is the rock, it will move all the way up. It will reach maximum height. If this velocity is taken as positive, then this rock will start moving from this point all the way back, right, to the surface. This will be taken as negative. So its height will be equals to distance covered, and in velocity time graph, that will be equals to area under graph. Okay. So here we have two graphs, different for the Earth, different for the Mars, and we have to find the difference between the maximum heights. Okay, so if you see, this portion of the velocities is positive. So at this point, it reach maximum height. For Earth, it is this point. Okay, so we have to find area under the graph till these points. So for the Earth, it is this triangle, and for the Mars it is this total triangle. Okay, so you have to find the area of the triangles and then you have to find the difference simply. So let's do it for the Earth. It will be 1 by 2. Base is, each box is equals to zero point 0.2, so 0.24681. It's 1.2 is the base and the height is 10, 11, 12, 12. Okay, and for the Mars it is 1 by 2 base into height. Base is till this point. So this is 2, 2.2, 2.4, 2.6, 2.8, 3, 3.2. So it is 3.2 and height is same as 12. Okay, so calculate both of them and find their differences. What you have to do, the height will be equals to area of triangle of Mars minus area of triangle of Earth. That will give you 12. It's option A. Okay. In the next video, in the next question, a block is released from the rest. Initial velocity is given, that is 0, and slide a distance x down a straight slope. The slope is at an angle of theta to the horizontal. The slope is frictionless and A resistance is negligible. A is equals to G. Okay, this is a very different scenario. Commonly, in case of slope, we don't consider this condition. But as they're telling us that the slope is frictionless, so it's just like the free fall that the object is moving down, vertically down. It will be acting like this. Okay, so we will not consider any horizontal thing because they have given us this special condition in that case. The acceleration is g, which expression give the final speed. So as we are going to consider this thing as the free fall given in the question, we will consider vertical components. Okay, so initial velocity we know they have given us 0, final velocity we have to find. Okay, and what else you have, acceleration is equals to g. Okay, and you need the vertical distance as well. Okay, so if you see, this is the distance traveled by the object on the slope, but this is the along the slope, it's not the vertical distance. I need, it was initially at this height and it's finally at this height. I need this thing, I need this distance, how much height is changed. Okay, so I can make this thing as a triangle. Okay, and if this thing is theta, this will also be a theta. So it's a triangle like this, in which this is theta, this is x, so this will be x cos theta, and this thing will be x sine theta. So distance, vertical distance is x sine theta. Okay, so s is equals to x sine theta. So now you can apply the equation of motion on this. Okay, we can apply v square is equals to u square plus 2as. We have to choose the equation in which time is not included. Okay, so final velocity you have to find, initial is 0 plus 2 into g into ss is x into sine theta. Okay, so you have to take the square root to cancel this square. It will give you v is equals to under root 2 gx sine theta. It's option B. Okay, in question 29, which equation represent uniformly accelerated motion? A straight line can be determined using only the equation, only the definition of acceleration. What is the definition of acceleration? It is rate of change of velocity over time. Change in velocity is v minus u divided by t. So if you rearrange it, it will be at is equals to v minus u. So v is equals to u plus at. Okay, so from definition you can find this equation. In the question 30, an object is moving from the rest with uniform velocity horizontally and uniform acceleration vertically. So ux must be equals to vx. Initial and final velocities in the horizontal are constant, and uniform acceleration vertically. So vertical component of velocity will be increasing because it is or constant acceleration. Okay, these are the conditions we have. Okay, so let's look at the graph. First graph is for the horizontal displacement and time. This slope is equals to velocity, displacement time graph, right? And this is decreasing slope. So this is decreasing horizontal velocity, and that is not the case. Okay, A is not the option. And B is a vertical displacement over time. So the slope, or you can say the velocity decreases. Which velocity? Vertical velocity. So that is also not the case. And C, horizontal velocity is again increasing, right? That is also not the case. And this vertical velocity is increasing. Vertical velocity increase. Okay, that is the case, right? Because this was the condition given to us. Okay, so we are done with the questions of the kinematics, and we will do in the next video, we will discuss the questions from the dynamics. Okay, if you have any question, any query, you can comment below and we can discuss it there. Thank you for watching.